Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on composite beam using generalized formulas we derived in first lecture of composite beam. So this is the question. A composite beam is constructed from a wood beam 100 mm into 150 mm actual dimensions and a steel reinforcing plate 10 mm wide and 12 mm thick. Okay, so you can see over here this is made of one material, that is wood, and this is made of steel, that has the cross sectional dimensions 100 into 12. So the wood and steel are securely fastened to act as a single beam. They will act as a single composite beam. So the beam is subjected to a positive bending moment M is equal to 6 kilonewton. Find the largest tensile and compressive stress in the wood and the maximum and minimum tensile stresses in the steel if E1 is given and E2 is given. See, here the bending moment is positive, means in our sign conventions anti-clockwise movement is positive. Okay, so anti-clockwise movement is positive means anti-clockwise movement is like this, right? So it is like this. Okay, this is positive bending moment which causes the positive curvature. The bending moment which causes the positive curvature is positive bending moment. So this is the positive curvature, right? So in positive curvature, the upper portion will be under compression and the lower portion will be under tension. So suppose the neutral axis is located here. This is the neutral axis. Then this whole portion will be under compression and niche ka whole portion will be under tension, right? So if you see, the material 2 will be wholly under tension. So it will have minimum and maximum tensile stresses. But if you see the material 1, it is under tension and it is also under compression. So it will have maximum compressive stress and it will have maximum tensile stress. And the minimum tensile and compressive stress will be 0. Okay. So this is how it will deflect. Now let us calculate. So first, what we said, first we need to locate the neutral axis. So we are saying that neutral axis is at distance h2 from bottom and at a distance h1 from uh, upper part of the beam. Okay, so we know that E1 integral y1 integral y dA plus E2 integral 2 y dA is equals to 0. From this we can calculate the location of the neutral axis. So we can write it as this as E1 into, we know that, see, if you write 1 y dA divided by A1 will give us y1 center of mass, right? So this will be integral 1 y dA will be is equals to y center of mass of 1 into A1, right? So that will be y center of mass. Y center of mass of this material 1 will be at this, right? This position. So this will be h1 by 2, right? So this distance will be how much? This will be at h1 by, sorry, this will be not h1 by 2, it will be h1 plus uh, something. See, we need to take this distance, that will be 150 by 2. So this will be 75, right? And this will be 75 mm. So this distance, how much this distance will be? So this is h. So this will be, this distance will be h1 minus 75. Do you agree? So it will be h1 minus 75 into area. Area is 150 into 100, right? Plus E2 into Y2. See, center of mass of centroid of material 2 will be over here. So it will be 6. This will be 6 mm, right? So and this distance can be given by h2 minus 150 minus this 6 mm. Okay, right? So this will be 156 minus h2 will be this distance, but it is below the neutral axis, so it will be negative. So h2 minus 156. So this will be h2 minus 156 into area. Area of that material 2 is 1200 mm square, right? So this is equals to 0, and we know the value of E1, that is 10.5, and we know the value of E2, that is 210, right? So we get 10.5 means 15,000 into 10.5 plus 210 into 1200. Sorry, this will be H1. So into H1 will be is equals to 1500 into 15,000 into 75 into 10.5 plus 210 into 156 into 1200. Okay. So from this we can find out the H1 value. That H1 will be is equals to, if you calculate the value, you will get value of H1. You get value of H1 as 124.8 mm. From that we can say the value of H2 as 37.2 mm. Okay. So we found out the H1 and H2 value. That means we located the neutral axis. Now what we need to find out? We need to find out the area moment of inertia of material 1 and material 2, means I1 and I2 about neutral axis. So see, I1 ka value about its center of mass will be 1 by 12 into BHQ, right? What is B? Sorry, this is B. That is the height is 150. So this will be about center of mass. This B value is given as 100. This H value of material 1 is 150, right? So this is about center of mass. So center of mass of material 1 is over here. So the distance is this one. This distance is h1 minus 75, right? So h1 we got as 124.8 minus 75. Okay. So we need to find out the value about this position. So we can write as I at any position. D will be given by I center of mass plus area of material into that D square. Right. So if you put those values and find out the value, you will get, so plus that AD square wala value. If you put those values, you will get the value of I as 65.33 into 10 power 6 mm4 mm power 4. Okay. And similarly, if you calculate the I2 value, you will get 118 into 10 power 1.18 into 10 power 6 mm power 4. Okay. I hope you can calculate the values of area moment of inertia. So now we can directly go and say that sigma x1 will be is equals to my by, sorry, we can say that E1 kappa into in terms of magnitude into y, right? So what is E1? E1 is E1, kappa will be m by E1 I1 plus E2 I2, that into y. So we already said that in material 1 it will undergo compression and tension. So the maximum compression will be over here. The maximum compression will be over here at top, right? So sigma 1 max compression will be is equals to E1 into m divided by E1 I1 plus E2 I2 into what will be the value of y? That will be this one, right? So that will be 150. That will be 162 minus H2. Okay. So 160 minus H2, 160 minus value of H2 is 37.2 mm. So we know the value of M, we know the value of E1, I1, we know the value of E2 and I2. So from that we will get the value of sigma 1 max compression. And sigma 1 max tension. See, material 1 is present up to here, right? So below the neutral axis it is tension and it will increase linearly. So the maximum tension will be at this contact plane C. So tension will be at contact plane C, that will be is equals to E1 into M divided by E1 I1 plus E2 I2. To that distance will be H2 minus 12. Okay. So H2 is 37.2 minus 12. So from this we can get the sigma 1 max tension value. So I will write down the value, you can verify. Sigma 1 max is minus 8.42 MPa and this value is 1.7 MPa. You can calculate and verify these values. Okay. Now we need to find out the maximum values, maximum and minimum values for material 2. So for material 2, sigma 2 max tension will be E2 into M divided by E1 I1 plus E2 I2 into the Y will be, see the material 2, if you see the diagram, the material 2, this one, this is the material 2. So the maximum tension will occur at the bottom plane, right? That is at B. So at B, and this one is at C, and it is at A. Okay. So this value Y will be is equals to H2. H2 is 37.2 millimeter. From this you can calculate the sigma 2 max tension. That value is 50.2 MPa. Okay. You can calculate. And sigma 2 minimum tension will occur at contact plane C. That will be is equals to E2 into M divided by E1 I1 plus E2 I2 into the distance. The distance is H2, 37.2 minus the 12 mm. Okay. So from this we can calculate the minimum tension in material 2. That value will come as 34 MPa. Okay. See, this is method 1. From method 1 we can calculate like this. First we need to find out the neutral axis. Then we need to find out I1 and I2. Then we directly apply the formulas of normal stresses. So I hope you understood this clearly. In next lecture we are going to solve same problem using transformed section method. If you like this lecture, do subscribe to our channel 9pointer for more interesting videos like this. Thank you.